In the question, you imagine you do not know the function. Actually, you do not know the function, right? But you know an equation the function satisfies. If you are looking for the derivative of the function, you have a problem in the nature that implicit differentiation. Okay, I will show you the solution to this question in more detail. Okay, now the solution. In particular, do not forget the Chen rule. You are going to see Chen rule is used all over places, so do not forget the Chen rule. Okay. For this question, I'm going to write everything in words so that you see what's going on. Okay. Maybe the first step, differentiate the equation with respect to x. You see all the terms are functions of x, right? We differentiate the equation with respect to x. I'm going to write down the word. Okay. Differentiate the equation. The given equation, okay, the equation with respect to x. With respect to x. So can I just write that with respect to x. That's my with respect to, okay, with respect to x. By that we mean you differentiate all the terms with respect to x. On the left hand side you have two terms. On the right hand side you have one term. Okay. So differentiate the first term, you have the power rule. You use the power rule. So that's simple. So that's the old stuff. Okay. You do not have to write any prime notation. So just get the answer to the first step. So by that we mean in some cases you need to apply the Chen rule, the product rule, the quotient rule in one step. So that's where I need it. Okay. The derivative of x to the power 5. I mean the derivative of x to the power 5, you apply the power rule. Okay. You have 5x to the power 4. Simple, right? Differentiating the second term, you need to use the Chen rule. If you want, you can write the derivative of the second term in the chat box. So do not forget to use the Chen rule. The answer to the derivative of the second term can be written in terms of f prime of x, but do not forget the Chen rule. So do you want to try to tell me the derivative of the second term on the left hand side? The whole thing is f of x to the power 5, choose u so that y as a function, so that the given function as a function of u is simple to differentiate. So just choose u to be the whole thing in the square brackets. So the second term as a function of u is u to the power 5. For u to the power 5, you can use the power rule, right? And then you differentiate u. I will write down the answer. It may not be too reasonable to ask you for the first question. Okay. So later on, I'm going to ask more questions. But you treat the whole thing in the box as u. You differentiate u to the power 5. Okay. Choose u so that the second term as a function of u is simple to differentiate. You have 5 times u to the power 4. I'm talking about the power rule. 5 times u to the power of 4. So that's u. Okay. U to the power of 4. You are not done yet. So because u is a function of x, you have to keep on going. Okay, to differentiate u. In this particular case, f of x is not given. It's an unknown function. So later on, you are going to solve an equation for f prime of x. So you just write the derivative of u in the following form: f prime of x. Okay. So later on, you are going to solve the equation for this. Okay, that's how to differentiate the second term with respect to x. Any questions? So that's essentially the new thing. That's essentially the new step. The new thing, I mean. And then differentiating the right-hand side is simple. 33, you treat 33 as a constant function of x. Okay. The derivative of 33 is equal to 0. The derivative of the constant is 0. Okay. Again, for step 1, I want you to complete the derivatives of all the terms in one step. Okay. And then we are looking for the derivative of the function. You see, you have an equation of f prime of x. So in the question, you have this. You look at the underlined thing. Okay. The next step, all you need is to solve that equation for the underlined. Okay. Okay. Just write solve the above equation. For the thing you are looking for. You see in the question, you are looking for f prime of x, right? The derivative of the function. For this thing, in many cases, it's simple. But in some cases, it could be a little bit long, but essentially the same thing. You keep all the terms involving the factor f prime of x on one side of the equation, and then you move all other terms to the other side. I'm going to make my point, okay? You look at the mouse cursor. This is the term involving a factor f prime of x, right? You leave that term on either side. So maybe in this particular case, on the left-hand side, you just keep that term, okay? You have 5 times f of x, the whole thing to the power of 4, right? And then times f prime of x. That's a term involving a factor of f prime of x. And then you move all other terms to the other side of the equation. I know this thing is simple, but in some cases, after the first step, the function can get a little bit long, a little bit ugly, but still the same thing. Okay, move the other term to the other side of the equation. You have negative 5x to the power 4. You know how I get the negative, right? And then solve the equation for f prime of x. Of course, it's permissible to cancel out a factor of 5 from two sides of the equation. You could do that in the first step, or you could do that here. It doesn't matter. But now we're ready to have the final answer. The final answer I'm looking for is the following. On the numerator, after canceling out a constant factor of 5, on numerator you have x to the power 4. So maybe negative x to the power 4. But it looks nicer if you write the negative sign before the whole function. And then on denominator you have f of x to the power 4. This thing can be treated as the final answer. I want to repeat, this thing can be treated as the final answer. The form may not be the same as what you are hoping, but in many cases it's impossible or very hard to solve the equation for f. You can leave the final answer in that form. So this is the final answer. Okay. Actually, in the future, the questions are not given in that format. Any questions on this? Any questions on this? The first step, so differentiate the equation. By that we mean differentiate all the terms. 2 terms on the left-hand side, 1 term on the right-hand side, right? In particular, the only new thing is how to differentiate the second term. Essentially, it's the chain rule, right? If you know what's going on with that term, then you're fine. Okay. the first step. So basically, the calculus step is only the first step. The next step is junior high school math. It's essentially how to solve an equation in that form. Okay, a times, so now let's say, so whatever thing, and then times b. You see, it's essentially that. Okay. If you don't have any questions, I will move on. Okay, I will move on. For the next question, I want you to look at your notes, to look at the first question, and then we'll go over the second question. Essentially, the two questions are the same, but in the future, all the questions are given in the format of question 2. I will show you the meaning. Okay. Okay, now in question 2, you have that. Essentially, you see you have the same function, but in the future, all the questions are given in terms of y instead of f of x. I'm trying to say if you replace y with f of x, question 2 becomes question 1. So do you see it? For this one, I'm going to write all the wordings as well. So this is the second question. I'm going to write all the words. Okay. Step 1. What I'm trying to write. I don't know what I'm trying to write. Differentiate the equation with respect to x. So this time I'm going to add some more comments. Okay, you write a comma here. It's kind of important when you have a question like this. In all the cases, I want you to treat y as a function of x. Differentiate the equation with respect to x. When doing that, I want you to treating y as a function of x. Whenever you feel confused, replace y with f of x so that you will know what's going on. Okay, I will show you the meaning. On the left hand side, again, you have two terms. Differentiate the first term, you have 5x to the power 4. That's the derivative of x to the power 5, right? Now the new thing is how to differentiate a term involving y. The key thing is to treat y as a function of x. Okay. Now let's differentiate the second term. So this time, can I ask you to write in the chat box? So maybe somebody can. So tell me the derivative of y to the power 5 with respect to x, treating y as a function of x. How do you write the second term, please? I mean, how to write the derivative of the second term. So please try something. If you get this, then you almost got the new stuff. Treating y as a function of x. So try again, Brooke. You miss a little bit. Choose u to be 5, to be y. I mean, the derivative of u to the power 5. You have 5 times y to the power 4, right? Yeah, y prime. Include y prime. Include y prime is right. Sure, thank you. Okay. That's why I wrote treating y as a function of x. Choose u to be y so that, okay, you look at the box, okay? To differentiate that term, choose u so that the term as a function of u is simple to differentiate. You just differentiate y to the power 5. But so do not forget y is a function of x, right? whenever you have a function of x, you have to keep on going, right? So you have y 5 times y to the power 4 and then times y prime. That's why I said whenever you feel confused, replace y with f of x. I want to repeat, whenever you feel confused, replace y with f so that you know what's going on. Okay, for the second term, if you replace y with f of x, then you will know how to differentiate so this term better, right? So differentiate that term. You see you have to use the power rule. I mean, you see you have to use the Chen rule, right? So differentiate the whole u to the power 5. So you have 5 times u to the power 4 f of x is your u, right? So to the power 4. And then you see u as a function of x. You have to keep on going to follow that by f prime of x, right? And then after doing that, you can recover the y notation. Now you look at the right hand side, the underlined part, okay? The underlined part. If you use the y notation, it becomes 5 times y to the power 4, 5 times y to the power 4, and then times y prime. Okay. And then the right hand side is equal to 0. Again, in the first step, to differentiate the equation with respect to x, the important thing is treating y as a function of x. Wherever you see y, you treat y as a function of x. Whenever you feel confused, replace y with f of x so that you are going to see what's going on. Okay. So don't worry. So later on, we'll do many questions like that. So that's kind of the only new thing part. Okay, we keep on going. The second step is, of course, solve the equation for y prime. Solve the above equation for y prime. Y prime is something we're looking for. Okay. It's kind of isolate the term involving y prime. So you have 5 times y to the power 4 and then times y prime equals negative 5 times x to the power 4, isolating the terms involving y prime. Okay, the same as before. I think we have seen that, right? And then y prime is equal to negative x to the power 4 and then times y to the power 4. I think that's right. Any questions? Any questions? I think I can tell you the rule of thumb right now. So because y is a function of x, we treat y as a function of x. Whenever you differentiate a term involving y, follow the derivative of a function of y. Follow that by y prime. You will see the point many times. Okay, so just try to remember that. Okay. So that's question number 2. In the future, in the questions, you are not going to see f anymore. Okay, but okay, you are not going to see f anymore. Instead, you are going to see y all the time. Okay. Okay, now let's work on. Actually, question 4 is very simple. Okay, question 4 is very simple. Let's skip question 3. So because question 3 and 4 are the same, I will show you what I mean. Okay, so just in question 3, I use f notation. It's easier to see what's going on. In question 4, I use y, right, instead of f of x. But the two questions are the same. I'm trying to say, if you feel like it's hard to differentiate the second term, and then you look at question 3, so that you're going to see what's going on. Okay. I'm not nagging too much. So yeah, probably for this one, It's simple too. I will give you 2 minutes to try this question, okay? And then we compare the answer. I will start to go over this question at 18 for 18, okay? So please now you get a piece of paper and try this question, please. The question is actually very similar to the question we just did. My class time is precious, so please actually try something, okay? And then we can compare. Okay, you see the question is almost identical to the question we just did. It's question number 3 probably. Okay. The only difference is the right hand side. For the right hand side, you differentiate sine of x instead of 33 probably. Okay. And then be careful the second term, how to differentiate the second term. The second term as a function of y is y to the power 5, but y as a function of x. We treat y as a function of x. That's why I said after differentiating y to the power 5 with respect to y, follow that by y prime. It's always the case. Okay. So you have that. The second step is a little different. From here, so do not cancel out 5. Okay. In this case, you cannot cancel out 5. So because 5 is not a factor of the right hand side. Okay. Solve the equation for y prime. Isolate the term involving y prime. Okay. So you have 5 times y to the power 4, and then times y prime. I just leave the second term on the left hand side of the equation, and then you move all other terms to the other side. And you have cos of x and then minus 5x to the power 4. Okay. And then you divide two sides of the equation by the underlined 5y to the power 4. So you have y prime equals, on numerator you have cos of x minus 5x to the power 4, and on denominator you have 5y to the power 4. Okay. So this thing can be treated as the final answer. I'm trying to say in the final answer it's permissible to have y, but it's not permissible to have y prime. We are looking for y prime. Okay. The reason is that in many cases, probably not in this case, in many cases it's hard to solve the given equation for y. Okay. So that's why you can leave the answer like that. Any questions? Simple? Now let's make the thing a little bit harder again. Now let's work on question 5. The left hand side is the same. You know how to differentiate the left hand side with respect to x. Now look at the right hand side. Look at the right hand side. So just tell me one word. So tell me one word, please. To differentiate the right hand side, what rule you have to use? What differentiation rule you have to use? Product rule, quotient rule, chain rule? So please look at the right hand side of the equation. To differentiate the right hand side, what rule do I have to use? Please. Anybody? Product, right? Okay, you see the right hand side, you have the product of two functions. Again, we treat y as a function of x, right? You have the product of 6x and y, right? You have the product of two factors. One single underlined, the other factor is double underlined, right? You see what's going on, right? Okay, it's kind of the same idea. Now the solution. In step 1, the same thing. We differentiate the equation with respect to x. More importantly, treating y as a function of x. Okay. You have seen the first two terms, how to differentiate the first two terms. You have 3x squared, the derivative of the first term, and then plus differentiate y cubed first with respect to y first, so that's 3 times y squared. So do not stop here. Y is a function of x. We treat y as a function of x. We are differentiating with respect to x. So we have to use the chain rule, right? We have to use the chain rule. Or the rule of thumb, right after differentiating a function of y, follow that by y prime. It's always the case. Okay, I will give you 1 minute to try to differentiate the right hand side. If you can do it, then write the answer in the chat box, please. So please try to get me the derivative of the right hand side in one step with respect to x, treating y as a function of x. I'm waiting for you to tell me the right hand side. Use the product rule properly. Okay, use product. Try something, please. It's okay to make a mistake, so I know what comment I can make. If you get it right, that's better. So anybody want to try the right hand side? Can tell me the right hand side, please. Yeah, that's right, Brittany. I think. Yeah, that's right. Okay. So just in case you did not get it, I told you whenever you feel confused, replace y with the if notation, with f of x, so that you see what's going on. Okay. I'm trying to say, if you did not get it, then you differentiate. So this thing, 6 times x and then times f of x. Wherever you see y, you replace y with f of x. You differentiate that. Okay. So you see you have the product of two functions. Use the product rule properly. Okay. The first factor is single underlined. The second factor is double underlined. Okay. So differentiate the first factor. You have 6, right? And then times the second factor. Use the product rule properly. Okay. And then follow that by 6x, and then times f prime of x. You see the product rule in here, right? And then in the solution to the question, recover everything using y notation. So you have 6y and then plus 6x, and then times y prime. Okay, that's good. You see, you have a question involving the product rule. So that's why I told you at the beginning of the class to be able to do everything in one step. That's where I need it. Okay. The first step is essentially the calculus part. It's the new part. The second step is junior high school math. I'm trying to say if the whole question is worth 10 points, if you get the first step right, I can give you 9.5 out of 10. So do you know what I mean? I'm trying to say the first step is more important. The second step is junior high school math. Now let's do the second step together. Okay. The whole idea is to isolate the terms involving y prime. Okay. The second term, I'm going to underline this. That's a term, so that's a term. Okay. These are the terms involving a factor of y prime. So you put these terms on one side of the equation. So you have 3y squared. I'm just copying the second term on the left hand side. And then minus 6 times x, and then times y prime. Move all other terms to the other side of the equation. 6y is already on the right hand side, minus 3x squared. I hope I got this right. Okay. And the idea is to isolate the term involving y prime so that we can solve the equation for y prime. Okay. And then from the left hand side, you take out a common factor of y prime. That's what we meant by isolating y prime. Okay. 3y squared minus 6x, and then times y prime equals. Finally, you have the answer. On top, you have that. On denominator, you just have okay. I went over the second step a little quicker, but it's simple, right? So just isolate y prime and solve the equation for y prime. Okay. Anybody has any questions? Or anybody wanting me to go over in some more details? Actually, in the final answer, it's possible to cancel out a factor of 3. It's nicer to cancel out a factor of 3. Okay. But if I do not want you to simplify, it's okay to leave like that. Okay. Okay. Any questions? If you don't, we move on. Okay. This time I'm going to change both the left hand side and the right hand side. Now let's look at question number 6. Okay, for this one, so before we differentiate the equation with respect to x, I think the question is in the nature. My intention is that in many cases you need to manipulate the terms a little bit so that it's easier to differentiate in next step. The first step, I'm not differentiating anything. I'm just rewriting the equation in slightly different form. So that's what I meant. Okay. Now the solution. You see, it's in order. It's easier to differentiate. The first term is essentially a power function of x. The second term is essentially a power function of y. I'm trying to write the two terms as in terms of the power functions. I'm trying to say x to the power of. I think all of you guys have no problem with that. Although there are some typos on the midterm. I know these are typos. But the first term can be written as x to the power of 4 over 5. You know that, right? And the second term is y to the power of 4 over 5 equals x times y. And then we are ready to differentiate the equation with respect to x. Now remember, in the first step, I did not do anything. I meant I did not differentiate anything. Okay, I was just rewriting the equation in some nicer form. Can I say nicer? And then the main step, the key step, differentiate the equation with respect to x. The first term is simple, right? All of you guys know that using the power rule. So this is the particular case when n value is equal to 4 over 5. The derivative of x to the power of n is n times x to the power of n minus 1. I think n minus 1 you have negative 1 over 5. And minus, differentiate the second term, you have 4 over 5 times y. I'm trying to say, using the power rule to differentiate y to the power of 4 over 5, you have n value is 4 over 5. You have n times y to the power of n minus 1. I think you have negative 1 over 5. Okay, now tell me, so did I differentiate the second factor correctly? So tell me what's missing. What's missing, please? So just tell me what's missing. Yeah, y prime. If you see what's missing, then you got it. Y prime. So because we treated y as a function of x, the rule of thumb is whenever you differentiate a function of y, you follow that by the derivative of y, by y prime. Okay. We missed the y prime in here. That's actually a common mistake. So do not forget that. Okay. And then, so do you want to try again to tell me the right hand side? After differentiating the right hand side, so what do you get? Differentiate the right hand side with respect to x, treating y as a function of x. Yeah, that's right. That's right, bro. Actually, for the right hand side, I know a common mistake. If you tried and had this 1 times y prime, then I know what you did. You did not use the product rule properly. Okay, so do not use the product rule so that way. In many cases, if I'm telling you, you know what's going on, but after you have many other things altogether, then you could forget. You have to use the product rule properly. Okay, the proper way to differentiate. So now let's say x times f of x is to use the product rule the following way: the derivative of the first factor, so which is f, right, and then times, I'm trying to say the derivative of x is 1 times the second factor, and then plus the first factor times the derivative of the second factor. So that is the proper way. Now using the y notation, you have y plus x to the x times y prime. Okay, that's what Brooke told me. Y plus x to the power of y prime. Okay. So we have done the first step properly. I told you the second step is essentially junior high school math, but still you need to know how to do that, right? Isolated y prime, so just one thing, right? Isolated y prime. So this time it's probably easier if you put everything involving a factor of, I'm trying to say it's probably easier if you put all the terms involving a factor of y prime to the right hand side of the equation. By that I mean, now I'll get the right hand side first. Okay, on the right hand side you have x times y prime, and then the underlined term is a term involving a factor of y prime, right? You move that term to the right hand side. So be careful to copy everything properly. Okay. And then on the left hand side, whatever remaining, you put everything on the left hand side. I think minus y, is that right? Okay. That's whatever you got. Okay. Yeah, so that's what I meant by isolating y prime. You're not done isolating yet. But can I jump a tiny little bit? From these two terms, I mean from the two terms on the right hand side, you can take out a common factor of y prime so that it becomes a factored form as follows. I'm just jumping a tiny little bit. I hope it's okay. But I told you why, right? And then you solve the equation for y prime. So yeah, this is long. You just have to copy everything. I will try to see if I can copy everything. That's what I meant by solving the equation for y prime. This is a point with x coordinate of 1 and y coordinate of 2. You see that's a point on the graph, right? Now in the question, using the derivative of y prime we just found, we can compute the equation of the tangent line to this curve at this point. Okay. Now let's work on that. Now the solution. So first of all, we do need to make sure this is indeed a point on the curve. By that I mean, if you plug x value of 1, you look at the mouse cursor, and the y value of 2 into the equation should be satisfied. Okay. Now the solution. The first thing we do is to verify the point is indeed on the curve. So maybe when x equals 1 and y equals 2, you compute the left hand side, or in some cases you compute the left hand side and the right hand side. You want to make sure the two sides are the same. Okay. We have the left hand side is is 1 to the power 5 and then plus 2 to the power 5. Again, you replace x value with replace x with 1. You replace y with 2. Okay, 2 to the power 5 is indeed, now we compute the left hand side, is indeed 33. You see the equation is satisfied, right? When x value is 1, when y value is 2. So the point with x coordinate of 1 and y coordinate of 2 is indeed a point on the curve. It's on the graph of x to the power 5 and then plus y to the power 5 equals 33. Okay. I used the computer sketch to show you what's going on, but in order to get the equation of the line, you do not need the graph, right? Can we start over? I think some people still came in late. I want to start over. Okay. Now, in order to get the equation of the line, we need two things. We need a point. You are given a point. Okay. The main thing we need is a slope. Okay. Now let's try to get the slope. So what is the slope? The slope is the derivative y prime in whatever situation. It's the derivative when x value is 1. In this particular case, when y value is 2. Okay. So that's why we differentiate the equation. Okay, now the next step we do is to differentiate the equation with respect to x, treating y as a function of x. Okay. Now we differentiate the equation. With respect to x. Of course, treating y as a function of x. Okay. Term by term. To differentiate the first term, you have 5x to the power 4. We have seen that many times already. Okay. And then plus y to the power 5y to the power 4. So differentiate y to the power 5. So do not forget y is a function of x. You have to follow that by y prime. Right. The right hand side is equal to 33. Right. I mean, the derivative of the right hand side is gone. 0. It's 0. Okay. And then we solve the equation for y prime. So we have seen that many times already. Okay. Can I squeeze it here? So y prime is equal to negative. I think we had something like x to the power 4, and on denominator you have y to the power 4. You check your question 1 or question 2. We got this already. Okay. This is so now the slope. The slope is a number. I know on the graph you kind of see it's you look at this part. You could guess the slope is 0. So but it's very tiny, but it's not 0. You look at this part. Okay. You draw a tiny line here, you might guess the slope of the tiny line to the graph is equal to 0. But it's not 0. How can we get the slope? We use x value of 1 and y value of 2 to plug x value of 1 and y value of 2 into this form. Now when x value is 1 and y value is 2, you're going to see the number is actually very tiny. Okay. And y is 2. We have y prime equals negative x value is 1, y value is 2. Okay. I think on numerator you have 1, on denominator you have 2 to the power 4. So 16, is that right? 1 over 16. I told you the number is tiny. Okay. It's kind of a negative slope. A negative slope. I don't know what I'm doing. A negative slope is it's going downhill, right, from the left to the right. This is the slope. I'm going to write one more word. Long wording. Okay. This gives the slope of the tangent line. Right. Now you have a point, you have the slope, you are ready to have the equation of the line. In whatever form you want. I still prefer to write it in the point slope form. You have a point, you have the slope. Now the equation of the line is, the equation of the tangent line is y minus y coordinate of the point, so which is 2, right? Equals the slope, negative 1 over 16, and then times x minus x coordinate of the point, so which is 1. Right. Again, so question number 10 is designed for a simple application of implicit differentiation, so we just learned. Okay, so any questions on this? If you don't have any questions, we'll move on to do some slightly harder questions. I do not want to call them harder, as long as you know what's going on, as long as you know the product rule, you know the quotient rule, you know the chain rule, you know treating y as a function of x, then all the questions are kind of similar, right? So just in some cases the functions are looking a little bit longer, a little weird. Now we'll do question number 7. You have an equation involving x and y. We are looking for y prime. So by that we mean differentiate the equation treating y as a function of x. I want to repeat, the keyword is to treat y as a function of x, not the keyword. Keywords. The first step, the left-hand side is simple. The left-hand side, the derivative of the first term is x to the power, 5x to the power 4. The derivative of the second term is 1 equals the derivative of y is 1, right? Anybody want to correct me? That's actually a common mistake. Anybody want to tell me how to replace the underlined, how to correct the underlined thing? The key is treating y as a function of x. It's y prime. Y prime is right. Okay. We treat y as a function of x. You could treat y as the derivative of y with respect to y, but after that you have to follow this by y prime. I told you the rule of thumb before, right? Right after you differentiate the function of y with respect to y, you follow that by y prime. It's because of the chain rule. Okay, so that makes sense. So now here you have 1 times y prime. Yeah, that's okay. But 1 times y prime is y prime. The same thing, right? Do you want to try the right hand side? So this time the right hand side is a little bit complicated. So maybe you want to tell me so what rules you have to use. For the right hand side you have to use 2 rules. Okay, I will give you some hint if you do not see what's going on. For the right hand side, use the chain rule followed by the product rule. You see you have to choose u. Differentiate the cos of u first. You treat the whole u, the u as the whole thing in the box. And then to differentiate the box, you have to use the product rule. Use the product rule properly, okay? I will give you 2 minutes to try to get me the derivative of the right hand side. Differentiate the right hand side with respect to x, please. I will give you 2 minutes. Again, whenever you feel confused, you replace y with f of x so that you can see what's going on. Okay. I will do that again. So maybe the last time. Whenever you feel confused, I will write the answer first. Okay. Chain rule followed by the product rule. You apply the product rule to the box part, treating y as a function of x. I think you're going to have 2x and then times y, right? And then plus x squared times y prime. That's the answer. Okay. I ask you to try, but if you did not get that, I will do that again. I said whenever you feel confused, replace y with f of x so that you can see what's going on. Okay. I will do that in here. So later on, I'm going to remove that anyway. Okay. X squared and then times replace y with f of x, and then you differentiate the right hand side cos of the whole thing in the brackets. You differentiate that with respect to x. You can do it in as many steps as you want, but when you show your work, you just show one step. Okay. You have to choose u, right? So that the function as a function of u is simple to differentiate. Choose u to be the whole thing in the box. Differentiate cos of u. You have negative sine of u, right? Negative sine of u. I said u. I'm going to copy the whole thing in the box in here. Okay. X squared times f of x. That's sine of u. I mean negative sine of u. Okay. The derivative of cos of u. You are not done yet. You have to follow that by, I'm going to do it in multiple steps. You have to follow that by the product rule. I mean, by the derivative of u. X squared times f of x prime that. Okay. I mean, differentiate that. Nobody say prime that. Differentiate that. Okay. So you have negative sine of x squared and then times f of x. And then for the remaining part, you use the product rule. Okay. The derivative of the first factor, you have 2x times the second factor, and then plus the first factor times the derivative of the second factor. And then you recover the notation using the y notation. Wherever you see f, you replace f with y. So do you see you have the right hand side? Right. Again, I did that again for the people who may not get the proper right hand side. Okay, now the next thing is to solve the equation for y prime. So this one is going to be a little ugly. The idea is still to isolate y prime. Okay, to solve the equation for y prime, the idea is still to isolate y prime. But for the right hand side, you need to do a little bit more work. So break it down first before isolating. Okay. By that I mean now we're on the second step. It's essentially the junior high school math. I'm copying the left hand side, 5x to the power 4 and then plus y prime. I know it's simple, but still you need to know how to do that. Okay. So break it down. By that I mean you multiply them out. Do that first. So negative sine of x squared y and then times 2xy, right? I just leave the whole factor 2xy in here. It doesn't matter. In most cases, you do not have to simplify. Okay. The thing is going to get a little ugly. Okay. So minus negative sine of x squared y and then times the other factor is x squared and then times y prime. Probably I did not write that super clearly, but I had x squared. I had y prime here, so that's what I meant. Okay. Now do you see it's easier to isolate y prime now? Leave every term, leave all the terms involving a factor of y prime on one side of the equation. Okay, y prime plus, you copy the entire underlined term to the left hand side. Move all other terms to the right hand side. You see this? This thing is ugly. I call this ugly. So what the other thing? Minus 5x to the power 4. I'm going to jump a tiny little bit. Okay. From two factors on the left hand side, I'm going to take out y prime. There remains 1 in the first term. So do you see what's going on? That's y. Okay, you know what to do in the next step. You just okay. I'm gonna write everything. That's the numerator over that's the final answer. On the screen you have the final answer. Still? Does anybody see anything wrong? Actually, I feel dizzy when I see ugly math. I'm not saying anything negative about calculus. So this thing is sometimes indeed ugly, but it's very, very useful. It's kind of one of the most important human discovery in history. Alright, then 7. So any questions on this? If you don't have any questions, we'll move on to 8. Homework for 8, we do not make the thing too complicated. We just do the first step. I just want you to differentiate the equation with respect to x, treating y as a function of x. Now the solution, I'm only looking for the first step. So this time I do not give you any hint. So please try to get me the first step, please. Differentiate the equation with respect to x, treating y as a function of x. Probably I want to give you some hint. For the underlined term, use the product rule. Okay. For the double underlined term, use the chain rule followed by the product rule. For this one, I'm only looking for one step. On the assignment, I will have some questions, differentiate the equation only. Okay, do not solve for y prime. We only do the first step. I will give you 2 or 3 minutes to try. Okay. I will go over the question at 14 probably. Okay, you have tried. The left hand side, x 5x to the power 4, the derivative of the first term, right? And then to differentiate the second term, you have to use the product rule. You see, you have the product of two functions. The derivative of the first factor, I'm talking about the box term, so this time I'm going to box it. Okay. The derivative of the first factor, so do not give me 1, so give me y prime. Okay. Y prime is the derivative of the first factor with respect to x. Again, whenever you feel confused, to replace y with f so that you can see what's going on. Okay. And then the second factor, and then plus the first factor times the derivative of the second factor. The derivative of sine is cos, right? Did I get this right? I did not make any mistakes on purpose. Now the right hand side is going to be a little bit long. I will write the equation in here. Okay. The derivative of cotan, you do need to know the basic formula. Is negative cosecant squared, right? Cosecant squared of x squared, and then y squared. Now to differentiate x squared times y squared, you'll have to use the product rule again. I'm trying to say you have to differentiate x squared times y squared. So differentiate that again with respect to x. In the brackets, the derivative of the first factor, you have 2x, and then times y squared, and then plus x squared, the first factor, times the derivative of the second factor, so which is 2y. Thus, the right hand side. So did I miss something? Did I miss something in the brackets? Yeah, y prime. Do not forget to follow that by y prime. Okay. I'm trying to recall some common mistakes. And then if you want to do the second step, we're not doing it. Okay. So break down the right hand side and reorganize and isolate y prime. The same idea. Actually, I do not really care that much about the second step. The first step is the calculus part. That's question number 8. We're not going to do question number 9. Okay. Eventually, you are going to do it. I'm trying to say question number 9 is one of the assignment question. You'll see if you look at question number 9, differentiate the second term on the left hand side. You use the product rule. Now the right hand side, to differentiate the whole thing, you have to use the Chen rule followed by the quotient rule. You see, you have the quotient of two functions. But at this point, if you have been following me, then you should be okay to differentiate the right hand side. Okay. Again, the right hand side is in the nature that the Chen rule followed by the quotient rule. Any questions? So question number 9 is going to be one of the questions on the next assignment. If you don't have any questions, I will convince you. What do I do next? We still have a little time left. I will convince you. So how about we do some textbook questions? So we'll do one of these. So how about we choose a harder one? Okay, we choose a harder one. So which one do you want? So there are 4 questions in the additional exercises on the textbook. I never did those questions before either. But let's try. Okay. So how about we do C only? Okay, we do C only. I'll try to see if I can save a little time for another little thing. So please try to do that independently a little bit, and then I'll go over that. I'll give you 2 or 3 minutes. So just start to try it. Okay, I'll go over at 21. This one is probably simpler than the sub questions we did. Differentiate the first term, you use the product rule followed by Chen rule. Product rule followed by Chen rule. Okay. I think that's the only tricky part. The first step only, please. I intentionally missed two y primes at two locations. On the left hand side, so there are three terms. So tell me in which two terms I missed y primes. So just tell me. I'm trying to make the question simpler for you to answer. I missed two y primes in two terms. So tell me in which two terms I missed y primes. Yeah, the second term and the third term on the left hand side. I'm trying to say I did not include a y prime here, so which is a big mistake. Do you see why? After differentiating sine of y, that's a function of y, right? You have cos of y. I told you before, because we are using Chen rule. After differentiating a function of y, you follow that by y prime. And also the third term. In the third term, I missed a y prime here. Now 3y squared is only the derivative of y cubed with respect to y, right? You have to follow that by y prime. Okay, we are not moving on to solve the equation for y prime, but if you really want, I think it's easy, right? It's simple. All right. I still have about 20 minutes. Okay, I'm trying to decide what to do. Can we move on to talk about the next topic? It's closely related. Closely related. Okay. Actually, before doing the next thing, I'm going to review some properties about the logs. Okay. I want you to recall three properties about the logs, in particular natural logs. The following three properties, you learn those in high school. Okay. One property I want you to know is that log of a times b. I'm just using natural log. Okay. The property is actually true for any log. Natural log of a times b is equal to natural log of a and plus natural log of b. So that's one of the three properties I want you to know. I'm going to use later very shortly. Okay. And then the second property I want you to know is natural log of a over b, the quotient of two things or two functions, two numbers, two whatever things, is equal to natural log of a minus natural log of b. And then the third thing, the last thing I want you to know is natural log of a to the power of b is equal to b times natural log of a. You can kind of, if you see a power in here, exponent in here, okay, you can kind of bring this b before natural log. You learned all these three properties in high school, in grade 12. I'm pretty sure in pre-calc 12. Why do I need the three properties for calculus, for differentiating functions in particular? So do you see the function of the natural log? In general, when differentiating, I think you have seen that already. We like addition better than multiplication, and we like subtraction better than division. So do you see how the log functions in here? This log will convert a multiplication to addition, and likewise this log will convert a division to subtraction. These things are going to be super useful when differentiating functions. And likewise, for the last ones, this thing will change any root to a number times a function of log. Okay. you're going to see what's going on very shortly. Now I'm going to go over. I think I have time to go over one typical question involving log. And by the way, the topic is called logarithmic differentiation. Logarithmic. Okay. It's essentially a combination of the property of logs and implicit differentiation. Okay. We'll go over a typical question. So how about we just do question 4? We do not need too many bridging questions, so we just do question 4. For question 4, the only way you can differentiate the function is to use the new method. I'm trying to say you cannot use power rule. So because exponent is not a constant, only when the function is in the form, so now let's say u to the power of n, when n is a constant, you can use the power rule, right? That's not the case. At u location is it's tan of x. It's not constant, right? You cannot also use the formula for the exponential function either. So because to use that formula, the base has to be constant. Now the base is not constant. You cannot use that formula either. Again, I want to repeat. Whenever you see the given function is one function of x to the power of another function of x, you have to use the new way. You have to use the logarithmic differentiation, the new way. That's the only way you can do for this type of questions. Okay. So because that's essentially the first question in this nature we're doing, I'm going to write all the steps. Actually, only one additional step. Then we can. Only one step in addition to the steps so we have seen before for the implicit differentiation. Okay, and then we can do that question. Now the solution. You take natural log of two sides of the equation. So can I just say take natural log of the equation? Take the first step is to take natural log of the equation, of the given equation. Okay, now let's see what we get. You take natural log to two sides of the equation. Okay, the left hand side now becomes natural log of y, and by the way, you treat the whole thing in here as the equation. Should I make it a little bigger? Better. And then be careful, the right hand side you need to use a few properties to make the right hand side a little better. Okay, I'm going to do this one a little slower. For the right hand side, you take natural log of the whole right hand side. It's cos of x, and then times, and then to the power of tan of x. The wonderful thing about the natural log is that you can use the third property, you look at the mouse cursor in here, to convert the right hand side to some form so that it's simpler to differentiate. I'm going to write one more line. Using property number 3, you have something like this. I'm not differentiating yet. Okay, the left hand side I just copy that. Now the right hand side is equal to. So do you see your a is cos of x, your b is tan of x, and then you can convert. You use that identity. You can convert this form to the form of b times the natural log of a, right? So your b in this particular case is tan of x, and then your a is natural log of cos of x. That's essentially the new thing for the new topic. Okay. That's step 1. We're done step 1. Sorry, I forgot x. I did not make that not mistake, on purpose. You see you have the product of two functions, right? Okay. And then you have an equation of x and y. Now you differentiate the equation with respect to x, treating y as a function of x. Okay. In the second step, differentiate the equation, the new equation, I mean, okay, with respect to x. Now it's the old stuff now, okay. With respect to x, still treating y as a function of x. Alright. That's the another key step. The first key step is to take natural log. The second key step is to differentiate the equation with respect to x, treating y as a function of x. So anybody want to tell me very quickly how to get the left hand side? After treating y as a function of x, what is the left hand side? If you can see the left hand side, then all the questions are the same now. So please differentiate the natural log of y followed by what? So please try to tell me the left hand side, please. Anybody? Try to get the left hand side. You know that. So please. Yeah, that's right. That's right. The derivative of natural log of y with respect to y is 1 over y. You need to multiply that by y prime. Okay. This is the derivative of natural log of y with respect to y, but y is a function of x. You have to keep on going. We are differentiating with respect to x, right? And then times y prime. Actually, for the new technique, the left hand side, I can tell you now, it's always the same. You're going to be convinced. Probably not today. You're going to be convinced on Thursday. Okay. The right hand side is simple. You see there are no y's on the right hand side. You just use the old technique. In this case, you have to use the product rule followed by the chain rule, right? I will tell you what's going on. So differentiate the first factor. So can I put some brackets in here? I'm doing that so because I want you to see so there are two factors. The derivative of the first factor, you have the derivative of tan secant of x, the whole thing squared, the basic formula, right? And then times the second factor, and then plus the first factor, tan of x, and then times the derivative of the second factor, for which you have to use the chain rule. So do you see you have to use the chain rule to differentiate the underlined? Okay. Choose your u. So the u is the whole thing in the box, right? It's the derivative of natural log of u is 1 over u. 1 over and then follow that by the derivative of u, so which is the derivative of cos of x, negative sine of x. Okay. You could simplify a little bit or combine something, but it's not necessary. It's not super necessary. Okay. For this type of the questions, I want to mention one thing, okay? So let's do me carefully. the final answer can always be written in terms of x only. I will convince you, okay? The next thing you do is to multiply the equation, to solve the equation for y prime. I think you can see the answer. It's kind of that. I'm going to write in 2 steps. As y prime equals, you multiply 2 sides of the equation by y, okay? You have y times the whole dot I said I would write the whole thing in 2 steps. I'll try to see if I can write the whole thing in 2 steps. I messed something up. I don't know what I did. This time I did it, I think. My final comment is that it's always possible to write the final answer in terms of x only. So because you have a relation between y and x, wherever you see y, you can replace y with the whole thing. You look at the mouse cursor. I'm trying to say the final step, okay? Y prime is written in terms of x only. It's going to be something like this: cos of x to the power of tan of x. You see the final answer. I hope it's not too squeezed, but the final answer. Why do I have this little a in here? I'm trying to say the final answer can be written in terms of x only.